In the center of the arid and ancient supercontinent Pangaea, thousands of miles away from the sea, our time-traveling aliens have returned to witness a key moment in Earth's history. As they arrived, the rain began to fall. Just off Pangaea's west coast, in what is now Canada, epoch-ending volcanic activity sent off a chain of events that all but made this downpour inevitable. It would never look the same, because this was the start of a rain that wouldn't abate for over 1 million years. A rain that changed the course of life on Earth. A rain that allowed the dinosaurs to take over the world in an evolutionary coup. What's all the more surprising to me, and to our aliens who witness life on Earth develop, is that the kind of event that caused this rain is, ordinarily, the most reliable and powerful extinction event the world has ever known. But this one was different. One that takes the butterfly effect to its limits. Imagine, if a butterfly flapping its wings can cause a tornado 1,000 miles away, what does an eruption 100 times larger than a supervolcano cause? I'm Alex McColgan and you're watching Astrum. Join me today as we discover how an extinction-level event 230 million years ago increased the richness of life on Earth and accelerated the evolution of the dinosaurs, learning as we move through Earth's major cycles how burning fossil fuels contributed to climate change way ahead of the Industrial Revolution. What came before the rain? Pangaea was the largest continent that has ever existed on Earth by a long way, a record not likely to ever be beaten given it was the size of every current continent combined. Its huge size meant that the center was far removed from coastal climates, and therefore received very little rain, favoring the evolution of species that required less water to survive. During this dry period around 300 million years ago, in the Carboniferous period, several species emerged that are still important today, including dragonflies, millipedes, and spiders. Throughout this period, the diapsids also exploded, a group containing lizards and snakes as well as archosaurs. Now, you may not know that name, but you certainly know what this group contains. Crocodiles, birds, and yes, eventually dinosaurs. But we'll come back to those later. If you've seen our previous episodes on ancient Earth, you'll know that it was a tumultuous and unforgiving place, with impending threats left, right, and center, and above and below for that matter. While asteroids smashing into the crust better grab the attention of Hollywood, it's under the crust where the real danger has always been, and it's here that we will find answers to what caused a million-year storm. We live on a vanishingly thin crust that is so shallow that if the Earth was represented by the entire Lord of the Rings book trilogy, the layer harboring all the known life in the entire universe would be confined to just one single page. Beneath, hot plumes rise up from the core, mushrooming as they rise and pushing molten magma up against the thin crust. These huge plumes punch through the crust wherever they meet it, completely ignoring continental fault lines where Earth's modern volcanic activity is concentrated, like the Pacific Ring of Fire. These plumes can release magma at the surface for over 1 million years, in what are known as flood basalt eruptions. It is these eruptions that are linked to the most incredible extinction events during Earth's history, and are probably the cause of the most destructive extinction event in history, the Great Dying, where ocean temperatures rose to 40 degrees Celsius. Despite life's ability to evolve, it is estimated that over 99% of every species that ever lived on Earth have gone extinct. Of course, you can't exactly evolve out of the way of a Mount Everest-sized asteroid traveling at 20 kilometers per second, but these volcanic processes, though slower and far less dramatic, can cause far greater devastation over a longer period. Evidence of flood volcanism is scattered across the world today. The eruptions of these flood basalts result in the creation of huge, unmistakable swaths of land, like the Siberian traps in northern Russia, the Deccan traps in western India, and the Wrangelian large igneous province across Canada and Alaska. They are all cooled flows of basalt rock kilometers deep, making them over 100 times larger than supervolcanoes. When we date these flood basalts, we see that many of these eruptions align with mass extinction events. There is one though that doesn't. That is our Rainmaker event that triggered the so-called Carnian Pluvial episode, or the time that it rained for over 1 million years. It's believed that volcanic activity in the Wrangelian province is responsible for this remarkable transformation of an arid desert into an oasis that jump-started the dinosaurs' explosion. So what separated Wrangelia's eruption from the rest? What made it different? Well, I've got news for you. Size does matter. Although this was an extinction event with around 30% of the ocean species wiped out during the CPE, Wrangelia's eruption was just the right size to give life an overall boost on Earth. So the reason that the overall biodiversity was unchanged is because the level of extinction was matched by the emergence of new, exciting species more suited to this wetter world. What our aliens witnessed was less an extinction event and more a reinvention period. So how can slow eruption affect such an incredible change to Earth's climate? To understand how this transformational event shuffled the deck of life on Earth is to understand something that we are living through right now: climate change. Specifically, the release and production of carbon dioxide and the release of stored methane. Eruptions like these directly release carbon dioxide already contained within the mantle, but they can trigger its release from other stores too, from a source of carbon I thought only humans had used: huge reservoirs of fossil fuels. Now, whether you remember the fire triangle from school or not, fuel, heat and oxygen, I think we can all appreciate that introducing 1600 degrees Celsius magma to the base of untapped virgin coal beds is going to get spicy. Burning these crude coal beds would have released incredible amounts of particulates and greenhouse gases, both important for driving cloud formation and rainfall. Just as we are seeing today, the increasing levels of those greenhouse gases trap more of the sun's energy, and that energy has to go somewhere. So where does it go? Earth systems work to distribute that energy, and the one best place to absorb this extra energy is the water cycle, which becomes supercharged. The sun's energy is absorbed by the land and sea, evaporating water from the surface. Once in the atmosphere, the water can be carried great distances before precipitating onto land and returning to the sea along a meandering route. The more energy that is trapped by greenhouse gases, the faster the water cycle turns over. In these flood basalt eruptions, we see an extreme example of the complex interplay of the three major cycles: the geological, carbon and water cycle. The formation of the Wrangelian large igneous province would have released huge amounts of CO2. Our alien ship detected atmospheric levels exceeding 1,000 parts per million, 2.5 times what they are today, increasing temperatures by 3 to 4 degrees Celsius. This supercharged the water cycle, greatly increasing evaporation and cloud formation, and these clouds were increasingly able to deliver rain further and further into the center of Pangaea. Throughout this period, the Earth became warmer and more humid, a dramatic change in the climate. Species that had adapted to a particular dry climate, environment or niche before the rain were put under stress from multiple fronts. During this turnover period in Earth's history, our aliens watched as old niches were seemingly destroyed as quickly as the new ones were created. The status quo was changing. Not only that, but species had to cope with a pH shift too. Carbon dioxide wasn't the only gas released by the Wrangelian eruption. hydrogen sulfide gas erupted into the atmosphere along with it. This egg-smelling gas reacted with oxygen and water to form sulfuric acid, which in this form is more well known as acid rain. As the rain fell, the soils and oceans became inundated with acidified water, which only further contributed to the environmental stress some species were facing. Interestingly, a large amount of amber can be found in the geological record from the Carnian. Amber is a protective mechanism for trees that they release when in peril, suggesting that plant life came under significant stress during this period too. The incredible volume of rain across the supercontinent resulted in deluges of surface runoff. Accelerating across and through the arid terrain, these slightly acidic flows eroded the land as it went. Some of this acidic water seeped into and eroded small fissures in limestone and dolomite rocks. Our aliens watched as rocks were literally dissolved in front of their eyes. Over time, elaborate new cave systems were formed, like Britain's Jurassic caves carved from Carboniferous limestone, which provided yet more unique habitats for life to exploit. Eventually, the flow reached the sea, carrying the eroded rocks and minerals into the ocean, further nudging the coastal ecosystems into new territory. The ocean species were particularly hard hit, and large areas became anoxic, meaning they lacked oxygen, and highly acidified, which was not suitable for the existing ecosystems that inhabit those areas. Species like conodonts, ammonoids, crinoids, and green algae suffered particularly high extinction rates during the CPE, as did reef builders, while dinoflagellates, a constituent of today's ocean planktons, thrived. On their ship, the aliens moaned in disbelief every time the ship's AI forecasted the ongoing miserable weather. But back on land, one of the oldest known dinosaurs, Herrerasaurus, was braving the elements and roaming the earth. Some 6 meters in length and weighing more than 300 kilograms, it was an outlier prior to the Carnian Pluvial episode when smaller reptiles and mammals were far more numerous. Its home was the Ishigualasto Formation, a volcanic floodplain defined by its dense jungle in what is South America today, a warm and humid environment which the Herrerasaurus was well adapted to. So when the rains began to fall, it won the geological lottery as its habitat spread across Pangaea. Advancing deeper into the continent, Herrerasaurus was greeted with literal oases. Untouched habitat that, with the extinction of herbivores and other competition, meant it was to be a boom time for the Herrerasaurus and similar dinosaurs. We can only imagine the variety and richness of habitat available for all these wandering species to find and exploit and co-evolve with over time. Further away in the Dolomites, the aliens saw herds of large dinosaur creatures roaming the plains, and their wandering footsteps have been recorded deep in the rock. Across a 3 to 4 million year period spanning the Carnian Pluvial episode, dinosaurs went from not featuring at all in the fossilized footprints to ecological dominance, making up over 90% of fossilized imprints. A remarkable takeover that agrees with other records in other parts of Pangaea during this time period, notably the Central European Formation and the Ishigualasto Basin in Argentina. The 2 million year period spanning the Carnian Pluvial event left its mark in indelible ways, forever changing the trajectory of life on Earth as well as the passage of water across and through its surface. The mega monsoonal climate featured 4 distinct downpours, each carving a trace through the landscape, making the biblical storm that remade the Earth in 40 days and nights look more like a typical British summer in comparison. But the 5th period of rain never came. Once the Wrangelian eruption finally slowed, the emission of greenhouse and acid-forming gases slowed, and it is likely that levels of carbon dioxide fell as it was consumed by the rich flora that covered Pangaea, some of which would again become buried and form coal fossil fuel deposits for us to use today, continuing the carbon cycle. Now the storm has passed, we can answer our question. If a butterfly flapping its wings can cause a tornado 1,000 miles away, what does an eruption 100 times larger than a supervolcano cause? Well, a complete terraforming of land, sea, and air. The aliens left, having witnessed the origin of the dinosaurs' dominance and a remade Earth. Some of the 180 million years after the extinction event that gave dinosaurs their big break, another would strike, wiping them from the face of the earth. For the earth giveth, and the earth taketh away. From that point, it has been the mammals who have come to dominate, including us humans. A remarkable reminder both times of how much can change on a geological whim, but that at each time of asking, as the rules change, life adapts and goes again. As life evolves, it gets better and better suited for the environment it finds itself in. This type of evolution isn't just tied to life though. The first way humans carried around their valuables was in leather pouches. Then, in the mid-1600s, when paper money was invented, wallets adapted into the bifold we often see today. But with the rise of credit and debit cards, it's no wonder that wallets are adapting even further. Today's video is sponsored by Exter, a company intent on making wallets and other products for the 21st century. My old wallet was quite bulky. It wasn't really comfortable in my jeans, so I really appreciate Exter's slim design. Their metal card ejector feature tickles the engineering part of my brain and makes it much easier to get out the card you want. Exter's Card Holder Pro is also evolving. Its new model is made using recycled aluminium, has a more ergonomic design, carries more cards, and can be upgraded with a tracker card that works with Android and the global Apple Find My network. It even notifies your phone if you move too far away. All in all, it's a really stylish wallet that can come in a number of different colors. You should give it a look, and by using my code Astrum at checkout, you can get a boosted discount of 30% off select Extra products, or follow my link in the description below to see what they're offering. Thanks for watching. I was honestly blown away by all the incredibly kind comments and messages you've sent me, and by the numbers of you that signed up to the Patreon. Like I said in the replies to your DMs on Patreon, everyone here at the Astrum team is so grateful to have such an amazing community. If you haven't joined the Patreon party yet, we're still on our long-term 1,000 Patreon member drive, so you can go to the link in the pinned comment to become a part of that effort. When you join, you'll be able to watch the whole video ad-free, see your name in the credits, and submit questions to our team. Meanwhile, click the link to this playlist for more Astrum content. I'll see you next time.